In today's session, we'll solve some of the exercises which are related with the Pelton wheel. Let us see what the statement of the problem that is given to us. A Pelton wheel is having a mean bucket diameter of 1 meter. Okay, mean bucket diameter that is given as 1 meter, and it is running at the speed of 1000 rpm. Okay, so the speed of the wheel or the mean bucket, so that is given to us 1000 rpm. The net head on the Pelton wheel that is mentioned as 700 meters. It is a net head. If the side clearance angle is 15 degrees, so side clearance angle is nothing but the angle phi. Okay, angle phi that is given as 15 degrees, and the discharge through the nozzle that is given as 0.1 meter cube per second. The discharge that is given as 0.15 meter 0.1 meter cube per second, and we have to evaluate the power which is available at the nozzle as well as the hydraulic efficiency for the turbine. Okay, so let us see what the facts which are given to us. So let us write down what the data that is given to us. The mean bucket diameter, so that we express as the capital D. Okay, mean bucket diameter, so that is given as 1 meter, and its speed that is given as 1000 rpm, so that is capital N, that is equal to 1000 revolutions per minute. The net head, capital H, net head that is given as 700 meter. The side clearance angle, so that is phi. Okay, the velocity triangle, if we see that the angle phi, outlet velocity triangle in fact, so that is 15 degrees. The discharge through the nozzle, so that is the capital Q, 0.1 meter cube per second. Okay, 0.1 meter cube per second, and we have to find out the power which is available at the nozzle and the hydraulic efficiency of this Pelton wheel, the given turbine. Okay, so let us see how to proceed with the solution. We can initially find out the tangential velocity of the wheel or the runner. Okay, tangential velocity of the wheel or the runner, that can be calculated as u, that is equal to pi into d into n divided by 60, that many meter per second, pi d n divided by 60. Okay, so plug in the values for the diameter, that is 1 meter, and revolutions, so that is given as 1000 rpm, and divided by 60. Okay, pi d n divided by 60, so we can calculate the mean bucket speed, tangential velocity of the wheel. So if I make the calculations for this one, so I can calculate this as u, that is equal to 52.36 meter per second. Okay, tangential speed of the, or the tangential velocity of the bucket, that is 52.36 meter per second. The absolute velocity of the jet at the inlet, okay, v1. So I know that the v1 can be given as cv, that is coefficient of velocity, cv into under root of 2g into h. Okay, under root of 2gh. So coefficient of velocity, so as such it is not mentioned to us, so it is safe to assume that the coefficient of velocity as equal to 1, okay, 1.0 into under root of 2gh, 2 into 9.81, that is the gravitational acceleration, and the net head that is given to me as 700 meters, so that is cv under root of 2gh. I assume the coefficient of velocity cv as equal to 1.0. So if I make the calculations for these numbers, I can obtain the velocity for the jet at the inlet, 117.19 meter per second. Okay, so the velocity of the bucket and velocity of the jet that I have calculated. Okay, that is u and capital V1. Okay, velocity of the jet. Now the first unknown that was there with me, the power which is available at the nozzle. So power available at the nozzle is nothing but the water power, that is the WP. Okay, this water power that is given as rho into G, okay, into Q, that is a discharge, into head, that is a net head. And if I divide this by 1000, so I can get the water power that is in kilowatt. So I know the density of the water, that is 1000 kg per meter cube. Gravitational acceleration 9.81. The discharge, so that is given as 0.1 meter cube per second. And the head 700 meters, and divided by 1000 to convert the power available in kilowatt. Okay, so after plugging this number and making all the calculations, so I get the water power, that is a power which is available at the nozzle, so very close to 686.7 kilowatt, 686.7 kilowatt. So this is my first answer. Okay, the power available at the nozzle. To evaluate the hydraulic efficiency, the second unknown, okay, hydraulic efficiency of the Pelton wheel, eta H. Okay, so from the derivation I know that this is given as 2 times V1 minus U into 1 plus cos of phi, 1 plus cos of phi, and divided by V1 square, divided by the V1 square. And if I multiply it by 100, I will get this hydraulic efficiency, that is in percentage as such. You will get that in percentage. If I put these numbers in this formula, that is 2 into velocity of the jet, that is calculated as 117.9, 117.19 rather, minus the velocity of the bucket or the tangential velocity, that calculated as 52.36 meter per second, into 1 plus cos of phi, so phi that is mentioned as 15 degrees, and divided by V1 square, velocity of the jet, so V1 that is equal to 117.19, okay, 117.19, and bracket squared multiplied by 100. So if I make the calculations for this one, I will get the hydraulic efficiency very close to 97.18 percentage. Okay, 97.18 percentage. Okay, so this is my required answer for the hydraulic efficiency. Okay, so this is as such a very straightforward or a simple exercise which is associated with the Pelton wheel. We also see one more exercise for the Pelton wheel. So this particular statement that reads as a two jet strike. So we are having a multiple number of the jets here instead of say using a single jet. So this particular arrangement for the Pelton wheel that consists of two jets. So double jet Pelton wheel is expressed or it is mentioned in this problem. A two jets strikes the bucket of a Pelton wheel and having a shaft power as 14,450 kilowatt. The diameter of both the jets, each jet that is given as 200 millimeter. If the net head on the turbine is 400 meter, find the overall efficiency of the turbine and assume or take this coefficient of velocity as 1.0. Let us see how to deal with the solution of this problem. So the number of jets which are used here, okay, I will write down number of jets Okay, two jets are used there, and having the shaft power. So SP is nothing but the shaft power, 15,450 kilowatt. Okay, 15450 kilowatt. The diameter of the each jet, so small d is nothing but the notation that we use for representing the diameter of the jet. So 200 meter, so that is 0.2 meter. Okay, diameter of the jet is 0.2 meter. The net head, that is 400 meter, and one has to find out the overall efficiency of the Pelton wheel, and you are supposed to take the coefficient of velocity equal to 1.0. Okay, so we know that this overall efficiency of the Pelton wheel, eta overall, so it is nothing but the ratio of the shaft power to the water power. Okay, overall efficiency is defined as the ratio of shaft power and water power. So the shaft power that is given to us 15,450. So it means that we have to evaluate the water power. Okay, we want to calculate the water power. So we know that the water power can be calculated by the equation rho into G into Q and multiplied by H, and if I divide it by 1000, I can get the water power in kilowatt. Okay, density, I know that it is 1000 kg per meter cube. Gravitational acceleration, that is 9.81. Discharge, so here I need to take the discharge from both the jets. So total discharge is nothing but the discharge to the single jet multiplied by the number of jets. Okay, so Q is nothing but the discharge passing through both the jets, and H, that is head, that is given to me. Okay, so I should calculate the discharge passing through the jet, right? So that is nothing but the number of jets. Okay, if I write down this as number of jets into discharge through the one jet. Okay, discharge through the single jet. So discharge of single jet. Okay, so number of jets, I know that two number of jets are used, and discharge is nothing but the area of the jet into velocity, it is nothing but the v1. Okay, v1 that is not known to me, so I need to find out the v1 velocity of the jet. So v1 that is equal to cv into under root of 2gh. Okay, so I can calculate this cv, that is mentioned as 1.0 coefficient of velocity, and under root of this 2 into 9.81, and the net head that is mentioned as 400 meter. So if I calculate this velocity of the jet v1, so it is obtained as very close to 88.58 meter per second, right? So I will substitute this velocity of jet in this formula. Okay, so that is nothing but the two number of jets into area of jet is nothing but the pi by 4 into d square, that is diameter of the jet squared. So diameter of the jet, that is given as 0.2 meter, and square of this one, so that is the area of the jet, pi by 4 into d square. And in the velocity, so I calculated as 88.58, right? So if I make the calculation for this one, so I can get the total discharge which is passing through both the jets, so that is obtained as 5.56 meter cube per second. Okay, so the discharge from both the jets of this Pelton wheel, so that is evaluated as 5.56 meter cube per second. So once I know this discharge, now it is easy for me to calculate the water power. Okay, so that is rho, density of the water, 1000 into G 9.81 into discharge, that is 5.56. Okay, rho into G into Q into H, that is 400 meter, and it is divided by 1000. So hence I will get the water power Okay, so this water power is obtained after the calculation as 21,817. So 21817.44 kilowatt. Okay, so that is the water power. So to calculate the overall efficiency, I know the shaft power that is given to me, and water power just now I have calculated. Okay, so I will plug in the numbers, I will put down the values. For the shaft power is given as 15,450 kilowatt, and divided by the water power, that is 21,817.44, and I multiplied by 100 to convert the efficiency in percentage. Okay, so calculate this one, and I obtain the overall efficiency of this Pelton wheel as 70.8 percentage. Okay, so this many percent is the efficiency, which is the required answer for the hydraulic efficiency of the given Pelton wheel. Okay, so these are the two simple exercises by means of which we can calculate the various parameters, various unknowns for the Pelton wheel. So as far as this session is concerned, so we'll stop here, and the other exercises for the Pelton wheel that we'll see in the next session. Thank you very much.